Hello guys, in this video I am gonna talk about determinants of special matrices. Okay, you already know triangular matrices, and here I'll give the expression for the determinant of triangular matrices. Okay, the determinant of an upper or lower triangular matrix is equal to the product of its diagonal terms. You see here upper triangular matrix, and its determinant is equal to the multiplication of diagonal elements, a11 times a22, and so on, ann. Let's prove that it's true. Our matrix is this: a11, a12, a13, a1n, 0, a22, a23, a2n, here 0, 0, a33, a3n. You see here diagonal elements will be a11, a22, a33, a44, and so on, ann. Here there is ann. 0, 0. Okay, this upper triangular matrix. Here first, over this column we use the linearity for the determinants. It will be a11 times 1, a12, a13, a1n, 0, a22, a23, a2n, 0, 0, a33, a3n. Here there is ann, and all elements below the diagonal are zeros. This. And then over the j's column we use this elementary operation. Instead of j's column we write j's column minus a1j times first column. Here j is greater than or equal to 2. From the previous lesson you know that if we use this elementary operation, then this determinant will not change. Because of this we can write a11 times the determinant of 1, 0, 0, 0, 0, a22, a23, a2n, 0, 0, a33, a3n. Diagonal elements will be 1, a22, a33, and ann. This one. As you see in the second column, all elements except a22 are zeros. Then we use linearity over the second column. It will be this: a11 times a22 times the determinant of 1, 0, 0, 0, 0, 1, a23, a2n, 0, 0, a33, a3n. This is ann, 0, 0, okay, this determinant. Then here we use this elementary operation. Instead of j's column we write j's column minus a2j times second column, and here j is greater than or equal to 3. third column, fourth column, and so on, nth column. Okay, from here, this expression will be this: A11 times A22 times the determinant of 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, A33, A3n. You see here diagonal elements are 1, 1, A33, A44, and ANN. And all elements below the diagonal will be zeros. This determinant. If we continue this procedure column by column, then in the end, the result will be this: A11 times A22 times ANN multiplied by identity matrix 1, 0, 0, 0, 1. Here diagonal elements will be ones, and all elements above and below the diagonal will be zeros. This. From the previous lesson, we know that the determinant of identity matrix is 1. Then it will be A11, A22 times ANN. That's all. Let's look at the second property. We know the definition of a diagonal matrix, and also we know that the diagonal matrix is a special case of triangular matrix. Because of this, the determinant of diagonal matrix will be the product of its diagonal terms. That's it. Let's look at this exercise. Calculate the determinant of minus in. Okay. Determinant of minus in is the determinant of minus 1, 0, 0, 0, minus 1. As you know, all diagonal elements will be minus 1s, and all elements above and below the diagonal will be zeros. This matrix is diagonal matrix. Because of this determinant will be minus 1 times minus 1 times minus 1. The number of minus 1s is n. Then the result will be minus 1 to the power of n. That's all. Let's look at the second part. For an n by n matrix A, calculate the determinant of lambda A as a function of determinant A. Okay. Suppose that A is this matrix: A11, A12, A1n, A21, A22, A2n, AN1, AN2, ANN. Then lambda A will be this matrix: lambda A11, lambda A12, lambda A1n, lambda A21, lambda A22, lambda A21 to n, lambda A n1, lambda A n2, lambda A nn. Okay, let's calculate the determinant of lambda A. Then the determinant of lambda A will be the determinant of lambda A11, lambda A12, lambda A1n, lambda A21, lambda A22, lambda A2n, lambda an1, lambda an2, lambda ann is equal to, here over the first column we use the linearity for the determinants. Then it will be lambda times the determinant of A11, lambda A12, lambda A1n, A21, lambda A22, lambda A2n, an1, lambda an2, lambda ann. This. Here we can use the linearity over the second column, third column, and so on, last column. It will be lambda times lambda times lambda times the determinant of A11, A12, A1n, A21, A22, A2n, an1, an2, ann. This. Okay. Here, as we know, the number of lambdas is n. Because of this, it will be lambda to the power of n, and this is the determinant of A. Okay, determinant A. You see, we expressed the determinant of lambda A as a function of determinant A. That's all. See you guys next lesson.